Hello, everyone. It's great to see everyone in 3D, finally. All right, so first of all, if you've come to other Droidcons and feel like this talk is missing something, it might be because it's the first workflow talk without my old teammate, Ray Ryan. So after talking about it for the last 4 Droidcons, we thought we'd give him a break. So who am I? My name is Zach Klippenstein. I've been doing Android for over 7 years. Most of that was at Square. I did some product work before joining the infrastructure team to help introduce Kotlin and coroutines and working on some architectural libraries. And then I did some work on the design systems team to help them start to adopt Compose as well. Last year, I joined Google to work directly on Compose itself. So today I'm going to give a brief introduction to what workflow is. I'll talk about how we built Compose integration into workflow, some stuff we learned along the way, and I'll take a look at how adoption is going so far. But why am I giving a talk about a project I worked on at my last job 6 months after leaving? Well, in my defense, I submitted the talk back when I thought this conference was going to be in fall, only 3 months after. But time really doesn't matter. There's a few talks this week you might have noticed about companies migrating to Compose, like if you were just here for the one from Twitter, it was really great. And while I think it's always good to hear more stories about what has and hasn't worked for people, I hope this talk can offer something unique. I want to highlight how the design of workflow put Square in a really good position to migrate incrementally, and some technical features of Compose that we were able to leverage to make incremental adoption really smooth. So if you did just see Chris and Nacho talk about how Twitter's adopting Compose, it's going to be a little bit different. I'm going to talk less about the high-level process and more about like the really kind of low-level technical details. So let's get started. This talk is called The Workflow Pattern Composed. What is workflow? It started as a pattern about 4 years ago when we realized that thinking about navigation as a centrally managed stack wasn't working anymore, and we needed something more flexible. It's since evolved into a set of libraries for both Kotlin and Swift that share most of their APIs and let Square developers design features for both Android and iOS at the same time. Square's been using workflows for a few years, and over 70% of their flagship POS app is built on top of this library today. So back when we were initially thinking about how to start using Compose, we didn't even really consider how to do that without using workflows. So why should you care? There's a few companies outside of Square using this library, but it's still pretty obscure. Well, what I'm hoping you take away from this talk doesn't actually have anything to do with workflows itself, but if you've worked in a code base that's been around long enough, you've probably seen it evolve its own idioms and shapes that work well for whatever you need. And whenever you do start to explore adopting Compose, you might run into some of the same issues we did. So I hope this talk acts as a bit of a case study that you might be able to refer to later on. It does help to know what workflow is, but I want to talk about more Compose than workflow, and so since most of the workflow concepts are pretty generic things that you've probably seen in other architectures, I'll just do a really quick intro. If you do want to learn more, we've given lots of talks and written some blog posts about it, and I'll have links at the end of the talk. So there's 2 sides to workflow. It lets you write business logic in a modular way, and it provides wiring for all the bits you need to build the view layer of your app. Let's talk about the non-view stuff first. Workflow is basically React for business logic and navigation. You write business logic as isolated, decoupled components called workflows that generate view models that we call renderings. A workflow can take some data called props, have its own private state, and then combine the two to emit renderings, which are just value types that tell the UI what to display at a particular snapshot in time. Renderings are just models. They don't know anything about drawing or input. Lastly, workflows can receive events from the UI through their renderings. They'll regenerate their renderings whenever anything like input data or internal state changes. So workflows are typically classes, which makes them really friendly to dependency injection, either by hand or using whatever library you like. So Square uses Dagger. Workflows form a tree. A workflow can ask other workflows for their renderings and incorporate them into its own. So renderings can contain other renderings all the way down. Props flow down and renderings flow up. That's how you write stuff like navigation and business logic with workflow. So this design has some advantages. Workflows integrate seamlessly with existing dependency injection solutions. Given a component, both its high-level business logic and its UI can be reused in multiple places in the same app very easily. Workflows and their views are easy to test in isolation. A test basically only needs to provide input data and assert on the rendering that gets spat out. Workflow code tends to have very low coupling, so it's easy to organize into fine-grained modules, which can be good for your build tooling and CI. And the drawing and input handling for a given workflow's rendering can be swapped out at build time or even runtime. In particular, this is what makes adopting Compose in a workflow-based app so nice. So all these things make migrating to different UI toolkits relatively straightforward. And this project really solidified our confidence that we made some good decisions early on. But we still need to turn those rendering values into actual views. A rendering is just a model that holds some data. You tell the workflow runtime how to create a view for each rendering type you need to show, and how to update that view anytime there's a new rendering. The logic that does this is called a view factory. A view factory is just another word for a controller presenter type thing. It configures a view with some data, but it doesn't have any business logic. We called them view factories in workflow because they're also responsible for creating views. So any part of your app can ask the workflow runtime to show any rendering value wherever it wants with a single line of code. And I'll show how that works in a bit. Remember that workflows form a tree, so do view factories. A view factory for a rendering that contains other renderings can, for example, do some fancy layout, then just ask the runtime to display views for the child renderings in the right slots. Individual view factories are entirely decoupled. They don't know anything about each other. In fact, it's common for composite rendering types to not even know what their child rendering types are and just use like a generic supertype like any. So let's see how this looks in code. A view factory is just an interface, generic on the type of rendering it knows how to display. Just to be clear, this code is in the workflow library. It's not something that an app developer would write themselves, but I will show samples of that later. So like any other factory, a view factory's main job is to build things. In this case, it's Android views. To do this, it needs the rendering value to build the view for. And it needs the actual value, not just the type, because it's also expected to initialize the view with this first rendering before returning it. It also needs a view environment, which is basically just Workflow's way of doing composition locals. The reason Workflow has its own type for this is because we needed a solution that worked for Android views before Compose even existed. So view environments are passed between all view factories, whether they're view-based or Compose-based or, I don't know, Flutter-based or whatever else you have. It also needs a regular Android context, so it can inflate the view. And it might get the view group that it's about to be added to, if one exists. So those last two parameters might look familiar from other Android APIs, like Layout Inflator, and it's the same idea. That's the view factory. So how do we connect one of these to a rendering? There's a few ways you could do it, but the easiest one is to make the rendering itself implement an interface called Android Screen, which just asks the rendering to provide its view factory as a property. Okay, time for the good stuff. Let's take a look at the new workflow APIs that we built to integrate with Compose and how they work under the hood. Since we just looked at what a view factory is, let's make one of those that can show a composable. We'll start with a type. Since anything that displays a rendering must be a view factory, let's start with subclassing that. Compose view factory is an abstract class, not an interface, because we want to override build view, but prevent subclasses from overriding our implementation. It creates a compose view, which is a view that's provided by Compose UI that can show some composable. ComposeView.setContent takes a composable function, stores it in the view, and sets up a compose runtime to measure and draw the view as specified by the composable. Where do we get that composable from, though? Let's define an abstract content function that actual view factories can override. And then we can just call that from setContent. There's only one thing we're missing now. It's not enough to just pass the initial rendering to content. We also need to update the content every time we get a new rendering. The workflow library provides some helpers to do this with views. This function, bind_rendering, sets up a callback that will be invoked whenever the view is asked to show a new rendering. The way it works isn't really important for this talk, but again, if you really do want to know, you can check out the code with the link at the end. The thing that is important to note is that it will also invoke the callback directly before it returns to initialize the view. So to keep the view updated, we just set the composable on the view every time there's a new rendering. That's it. That's the wiring we need to go from the view world to the compose world in workflows. Nothing that's using this class as a generic view factory has to know that compose is even a thing. Oh, there's one last goodie. Just like we had Android screen for renderings to declare their view factories, we also have compose screen for renderings that want to use compose view factory. We can just give it a content function. It looks just like the other content function on compose view factory, but you might notice it doesn't actually take our rendering as a parameter, because the rendering that it's showing is just this. And then we need to create a compose view factory. We'll override content and just call the content method on the rendering. All right, so that's compose view factory and compose screen. Let's look at some examples of how we might use them. This is about the simplest rendering you can write. So let's give it the ability to draw itself. First, we need to implement compose screen. We'll override content, and that's literally all we have to do. So that was too short of a talk. So to make it a little bit more complicated, let's say we want to show something else. So remember this diagram? View factories can form a tree and show other view factories for other renderings. So let's see how that works. Let's convert this name rendering to a person rendering and give it some more data. We don't know what kind of data. Different people might have different details about them that we care about, like maybe some people have an address or social media info. It doesn't matter. Our person model can take any details type. And as long as the workflow runtime knows how to create a view for it, we can show it. To get that on the screen, we'll show the name like before, but this time we'll put it in a column, and somehow we're going to show those details below it. So the way that we do that is with the workflow rendering composable. This is a function provided by the workflow library that takes a rendering value to display. It takes an optional modifier, which we use here to make sure it takes all the rest of the available space, and a view environment, which we just pass through. Let's look at how that works. This is the signature, just like we saw. So in order to create a view for the rendering, we need a view factory. That's where the view environment actually comes in. We can ask a view environment for the view factory for any rendering type. So we'll do that here. But view factories return Android views, and we're in a composable. So we need some sort of adapter to convert it. I'm just going to hand wave that for now, and there's a function called asComposeViewFactory that takes a view factory and makes it a composable view factory. I'll talk about how that works in a little bit as well, but I want to finish talking about this function first. So remember that composable content method that we saw on the compose view factory? This is where we actually call it. We'll ask the runtime for a composable view factory, and then just call it with the rendering. We also need to apply the modifier to the content somehow. So let's wrap that content call in a box and pass the modifier to the box. This propagate min constraints parameter might look a little strange. I haven't seen a lot of examples using it, but it's important here that we tell the box to propagate the minimum constraints that it's getting from the layout system, because by default, box will behave kind of like wrap content size, the modifier. It'll let its content be as small as it wants, and if that's too small for the minimum size, it will just center it in itself. But in this case, if the caller is passing a minimum size constraint down, they probably actually want the view factory's content to obey that minimum size. So we have to ask the box to pass it through. This is a pretty good start. We're not quite done yet. Remember this side? Can you think of any other ways to implement an overview detail screen like this? One way might be with fragments. These fragments. Who doesn't love fragments? Uh, one, one of the reasons Square started building its own architecture libraries long before I joined was because they didn't want to deal with these life cycles. Views and composables have much simpler life cycles. They're either attached or composed, and then they're not. Unfortunately, we still need to deal with the reality that a lot of Android code still expects certain lifecycle contracts. Compose, for example, relies on lifecycle events to initialize and clean up after itself. So that means that workflow still has to expose lifecycle events somehow. Android X provides the lifecycle owner interface, which lets anything at all define a lifecycle. So workflow needs to somehow expose a lifecycle so that anything inside the children of the view factory can see when the parent decides to stop showing it. That's pretty easy to do thanks to composition locals. We can simply create our own implementation of lifecycle owner and pass it down as the local lifecycle owner. So this remember child lifecycle owner is a composable function, and it returns a lifecycle owner that does two things. It reads the current local lifecycle owner value and mirrors that lifecycle state. And then when it's removed from the composition, it moves its state to destroyed. So why doesn't compose do this automatically? Well, like I said earlier, composables do have their own life cycles, but they're much simpler. They're present or they're not present. Pure compose code usually doesn't need to know or care about the full Android lifecycle. But view factories are actually more like fragments in spirit than just simple composables because we use them for navigation. When a view factory is removed from the composition, there may be content that's observing the local lifecycle, including other Android views or even nested compositions, and those need to be destroyed as well. So are we done now? Not quite. If you read this code carefully, you might have noticed a potential bug. We're remembering something that is derived from parameters to the function, the rendering and view environment parameters. What happens if they change? The caller can recompose at any time and decide to pass a completely different rendering with a different type. Because we're deriving the view factory from the rendering, but remembering it indefinitely, we'd end up with the wrong factory and crash when we ask it to show an incompatible value. One way to fix this would be to pass the rendering as a key to remember, right? Well, sure, that would kind of work, but then we'd end up recreating the view factory for every new rendering value, even if the type didn't change. So really what we actually want to do is key off the rendering's type. So let's pass that to remember. But remember all that stuff we just talked about, life cycles? If we create a new view factory to replace the old one, we need to tell the old one that it's being destroyed. We need to tear down the old life cycle and spin up a new one. So this key needs to apply not just to the remember, but also to the life cycle, and really just to the entire rest of this function body. Compose's aptly named key function is perfect for this. By wrapping the rest of the body in the key function, with the rendering type as the key, anytime an incompatible rendering is passed in, everything in the old view factory's content will be torn down. Effects will be disposed, the old lifecycle will be destroyed, and state will be recreated, including the view factory and the lifecycle. Now we're done. When we were writing this, it took quite a few iterations to boil it down to just this code. Being able to write remember child lifecycle owner only in terms of Compose's lifecycle concepts and composition locals, using stuff like disposable effect, turned out to be a really nice way to separate concerns. The code to manage the life cycles stays a lot smaller and easier to read, reason about, and test. At the same time, this key function makes it very clear how the rendering's type affects the behavior of the function. It's basically just one line, and the lifetime of that content is visible in the code itself with indentation and braces. So this demonstrates one of my favorite things about declarative code. This function has a relatively complex contract and behavior, but every line that isn't a single closing brace is load-bearing in some way and significant. There's virtually no boilerplate. The Android view version of this is super complex, and even when I was working on it every day, I could barely keep all of the parts in my head. I'd show you, but it's multiple files and hundreds of lines. So the other nice thing about this code is that in the actual repo, it has tons of comments. It's a bit of an eye chart here, but that's kind of intentional. You can go read them in the actual repo at the end of the talk if you want. But every line, pretty much every line, has a comment explaining its implications and why it needs to be there. I basically just took my speaker notes for this talk from the comments here. In general, I think it's a lot easier to write good comments that are actually helpful to people reading your code when everything that the comment is talking about is basically in that line that it's commenting on. Okay, so let's recap. We've hidden all the compose interop behind something called compose view factory. We've seen how one of these can show other view factories using the workflow rendering composable. And that's really it for the interesting bits of the public API. But there is one more piece I want to talk about. When you need to create a view for a rendering, you pick the type of view factory you need, based on whether you want to work with views or composables. And they'll work interchangeably. If you're in a compose-based view factory, you use the workflow rendering to nest children. If you're in a view-based view factory, you use something else that works very similarly, but for views. Either way, composables and views can be nested recursively both ways, and all the actual interop code is hidden in the workflow library. We already saw how that interop works in one direction, from compose to views, but what about the other way around? Remember this asCompose view factory function that I hand-waved before? Let's take a look at how that works. So compose view factory wraps a composable in a view. asCompose view factory does the same thing in reverse. So unlike everything else I've talked about so far, this isn't public API because all the interop is hidden, and this is just an implementation detail. So how does it work? First of all, if the view factory is already a compose view factory, we don't need to do anything. You just cast and return it. This isn't just clean from an implementation perspective. It means that if a whole bunch of compose view factories are nested, there's very little machinery between them. To illustrate, consider this pair of view factories. This compose view factory function, it's just a way to create a view factory without using the compose screen interface. The red factory shows the title red, followed by a string representation of the color, which I've also factored out into a different view factory. So let's do a little substitution to see what this content function is actually doing. Turns out it's composed all the way down. Even though view factory itself and all the other core workflow primitives only know about Android views, and they don't even know compose is a thing, here we stay in the compose world and we never jump out into Android views. This is good because while the workflow library makes interop seamless, there is still a bit of overhead required to convert between the two UI toolkits. So it's much more efficient to just avoid that altogether when possible. But what if the view factory isn't a compose view factory? Then we need to make one. So we'll implement the content function. And just like how compose UI gives us the compose view class to go from views to compose, it also gives us the Android view composable to go from compose to views. It has a number of overloads and default parameters, but the typical usage just involves passing two functions. A factory function that creates a view object from an Android context, and an update function that gets called and passed the view returned from factory, and it configures it. The factory function is only called once when Android view enters the composition. The update function gets called every time something changes, and as well as on the first composition. And then it's called again whenever anything changes and we need to update the view. So we'll start by implementing the factory function to create the view. And here we're just calling the build view function that we looked at kind of at the beginning of the talk. That's the function in the view factory interface. We'll pass along the rendering in the view environment and the context that we got from the Lambda. We're not going to pass that container view group because the container, in this case, isn't a view group, it's a composable. So now we have to make sure we update the view anytime this content method is recomposed with a new rendering. Remember this bind show rendering function I mentioned earlier? It installs a callback to fire whenever the rendering changes. So now we're actually going to call it. We'll use another helper from the library called show rendering, which just gets that callback out of the view and calls it. And we're done. That's all we need to turn a regular view-based view factory into a composable function. So these are all the major parts of the workflow compose integration. And I've said this a couple of times already in this talk, but I'll say it again. The most important feature of this project is that the interop between compose and views is seamless in both directions. This is really important because in large legacy code bases, migrating to a new UI toolkit can only happen incrementally. You're going to convert individual screens or maybe even smaller components one at a time. Workflow's compose support makes this really easy to do, one view factory at a time, without worrying about which other view factories are using which UI toolkit. One concrete example of how this can be useful is for some of the navigation helpers that Workflow provides. It gives you a special view factory that shows some nice navigation animations, helps restore view state correctly when navigating backwards, and other backstack navigation-related things. This view factory is built with Android views, but you could use it in an otherwise fully compose-based workflow app and never know the difference. So those are all the APIs that most developers are going to interact with, and all I'm going to have time to cover in terms of code today. We also added some compose-friendly entry points to the workflow runtime that are a lot cleaner than their view counterparts, and they make use of Compose's coroutine integration. But most workflow devs never actually see that stuff day to day anyway, so I'm going to skip over it for now. Instead, let's talk about some things that we learned. I ran into quite a few issues with the compose view interop early on. Luckily, by now, most everything just works. But back then, for example, if you had a deeply nested composition inside a view inside a composition, you had to manually wire up the composition contexts so that things like composition locals would get propagated correctly. Even more fun was that there was a few crashes that were hard to reproduce, and you only hit them when you hit certain levels of nesting. So we ended up reporting a lot of bugs as we were working on this, and to the Compose team's credit, they were very responsive about fixing this stuff. This was back like early alpha. So just to give you a sense, here's what Compose View Factory looked like in May 2020. It's a lot of code there to handle things that weren't supported yet. And now it looks like that. Compose View does pretty much everything for us automatically. Another one of those interop things that was really sticky was something called view tree owners, which is basically a pattern for emulating something like composition locals, but just in the view system. There's view tree owners for lifecycle, save state, and some other stuff. They're more flexible than the classic Android technique of just making everything a view or activity method to override, but they do require a bit more work. One of the compose bugs I found working on this project was that the Android view composable didn't set the view tree owners correctly from the associated composition locals. This meant that any compose-based navigation library, such as Workflow, would not be able to send the correct lifecycle and state registry to the Android views underneath it. It just wasn't possible. And that was the first bug I fixed when I joined Google. So luckily, most of this just works now. Unfortunately, there's still a related bug in Compose UI's pop-up, last time I checked, which still has to set the view model store owner on the pop-up's root view, but can't because the view model store owner composition local lives in a separate artifact that pop-up can't depend on because of circular dependency reasons. So we're still trying to figure out how to fix that. But you should only really notice that if you're using view models inside of pop-ups, which hopefully is not something you're doing too much of. One of the things that uses view tree owners is save state. Making state save and restore correctly across views and compose is pretty complicated when you're doing it by hand. Views have always had a mechanism for doing this with on save and on restore instance state. All views participate in that mechanism, at least in the sense that they dispatch calls to their children, if nothing else. This API is a little bit complicated. You return a parcelable to save state, you get a parcelable back to restore, but there's requirements on what that parcelable actually can be at runtime. They're not obvious and they're easy to get wrong. And only views that have IDs are actually restored. And there's some other stuff too. So Android X introduced something called save state registry. It has a very different API. To save, you register a state provider with a string key as a callback that returns a bundle. To restore, you simply ask for the bundle that you gave for that key. Keys must be unique to a registry, but they can be anything. And Compose has something similar. It's a multi-platform version of that just wraps it. It's called Save a Bool State Registry. And it's pretty much the same API. On Android, the Compose mechanism uses the Android X save state registry instead of the Vue one. But when you're building a navigation library for Android, you can't just pick one of those to implement. You have to support both if you want to support both UI toolkits. And if you don't, you see really subtle and sometimes hard to find bugs where you're saving state to the wrong scope. It's still saving and sometimes restoring, but not always the right way. What's really tricky is that the Vue mechanism and the Android X mechanism both have hooks for libraries that define their own state scopes, but they also have very different, very specific requirements about where in the Android lifecycle those hooks are invoked. And they're different for Vues and Android X. So for example, you can't implement support for save state registry without also having support for lifecycle owners, which meant we had to do that as well in workflows first. We also went back and forth a few times on how to use composition locals in this API or whether to use them at all. Earlier in the talk, I mentioned something called the Vue environment, which is basically Workflow's version of composition locals. We initially wondered, couldn't the Workflow Compose APIs just hide the Vue environment behind a composition local? Get sort of some boilerplate, and they kind of have the same concept, so it would kind of make sense. Well, the Compose team consistently and loudly urges everyone to resist the urge to use composition locals for everything. And like everyone does at some point, here we thought we had an exception. But ultimately, we realized we didn't. And avoiding them made just everything better. One of the things that it improves is that it serves as a good API hint that the workflow rendering function isn't supposed to be called from just any composable, but something inside of the workflow system. It also makes the new Compose APIs more familiar and intuitive to workflow developers who've been writing Vue-based workflows for some time. And as I said, Square's been using workflows for a couple of years now and has tons of them in the codebase. So that's quite a big number. Writing a production quality Android navigation library from scratch is really hard, or at least it used to be. Workflow wasn't Square's first Vue-based navigation library, but even with all of the lessons from previous attempts, it was still a lot of work and trial and error to get right. But if you are willing to take that on, being able to define your app's architecture from top to bottom in entirely your own terms is kind of priceless. And the good news is that Compose makes a lot of the tricky bits much easier to do correctly. So after all of this work, how are things going over at Square? Not too bad. While the workflow stuff was mostly already done by the end of 2020, we couldn't just start writing Compose code. Square uses their own design system that's not material, so we had to build a Compose version of that. This design system, the Compose version of this design system was released internally at the beginning of this year, and it took most of 2021 to build it out. And there's already about 120 renderings that are using Compose, and any new UIs are built with it as well. We've also got lots of samples on GitHub that show how the pieces fit together, and again, that link is coming. But it would be unfair to finish this talk without saying that while it still provides a ton of value, the workflow library still has some issues that, ironically, Compose might actually be able to fix. So workflow currently encourages immutable rendering classes. And so a tree of workflows produces a tree of immutable renderings. Immutable data is great, but sometimes it's not very efficient. Compose has something, I think it's called the snapshot system, that I've heard makes mutability not scary anymore. And it would be great to take advantage of this in workflow to allow individual renderings to update without recalculating the whole tree. Another issue is that workflow will immediately re-render the entire tree as soon as something changes. This can be wasted work since a workflow tree driving a UI really only needs to update once per frame, and Compose already does this. In fact, at this point, workflow is really just a clunkier implementation of Compose minus the UI parts. Everything it does, Compose does, and better. If we had started the workflow project today, we likely would have just used Compose directly. In fact, our friends over at Cash App had the same idea, and they built Molecule. That said, Square has a very large code base, and it's already full of workflows. So the fact that they can already take advantage of this migration path today is great without having to re-architect anything. So I covered quite a bit of stuff and didn't get close to talking about everything we built from this project or get it to go into as much detail as I would have liked. But Compose is a poster child for cool demos, and for a good reason. You can build a lot of really neat looking things with it and wow your users, or just your Twitter followers. Like, it's fun to do. But it's not just pretty pixels. There's some great design and API features for infrastructure devs as well. And I hope that I've been able to demonstrate some interesting ways to use Compose behind the scenes and keep not only your users, but also your coworkers delighted. Just before I go, I just wanted to say thank you to Ray and the rest of the foundation team at Square for early on being really willing to experiment with Compose, helping review this talk and giving the other workflow talks, and keeping the library running. And Leland Richardson as well. When I was working on this stuff like a couple years ago, he was super helpful and helped me debug some of the interop issues and just really responsive. And this was like before I even joined Google, so it was kind of a new experience, and it was a really positive one. And that's it. So thanks for coming, everybody. The QR code here links to these slides, so feel free to scan that and get all these links.